Hi everyone, this is your math guru. In this video, I'm going to solve the following problems that deals with the application of trigonometry. That is your angle of elevation and depression. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have Anne is on top of a building and observes a man on top of a taller building nearby at an angle of elevation of 16 degrees. If a building is 52 meters high and the other is 91 meters tall, how far in a direct line is Anne from the man? A quick recap: if we have an horizontal line, the angle of elevation is the angle above the horizontal in this direction. So this will be our angle of elevation. And measuring the angle below the horizontal line in this direction will be our angle of depression. Back to the example given, the diagram is shown. Anne is sitting on the top of the building that is 52 meters high. The man is on top of a taller building that is 91 meters high. The angle of elevation has been given as 16 degrees. To find the distance d, that is from Anne to the man, I'm going to draw a rough sketch of the right angle triangle formed. We have Anne, we have the man. This is a right angle triangle. The angle of elevation has been given as 16 degrees. We have to find d. However, to find d, we need to find the distance such that if I extend the height of Anne, the total distance given is 91 meters, that is of the man. To find the distance, the remaining distance, we're going to subtract the distance of Anne from the man. That is, we have 91 meters minus 52 meters, and that will give us 39 meters. So this is 39, and we have 39 here, 39 meters. Therefore, to know the trig ratio to apply, we need to tag all the sides of our triangle. The side facing the angle, as shown, will be our opposite. The longest side, or the hypotenuse, which is always positive, and the last side will be our adjacent. Now we are looking for hypotenuse, or d. We have our opposite and the angle. The trig ratio to use, we have a SOHCAHTOA. The trig ratio we're going to use is a sine, such that we have sine 16 degrees equals our opposite over hypotenuse, and in this case our opposite is a 39 meters over the hypotenuse, which is what we're looking for. That's d. So we have sine 16 degrees equals 39 over d. Sine 16 degrees is over 1, and if we cross multiply, we have d multiplying sine 16 degrees is equal to 39. To find d, we're going to divide both sides by sine 16. And if you punch that in on your calculator, 39 divided by sine 16 degrees, we have 141.49 to 2 decimal places meters. Let's look at the other example. We have Julia observes a car approaching on the desert plain from a position on top of a 30 meters cliff. The angle of depression of the car at that instant is 47 degrees. How far from the base of the cliff is the car? So we have Julia on top of the hill or the desert plain, and our angle of depression while observing the car has been given as 47 degrees. Remember, the angle of depression is being measured from your horizontal. Then we have the car at the bottom. We have to find how far the base of the cliff is from the cloud. Note that because the angle of depression is being measured from the horizontal, then this horizontal line is parallel to the distance between the car and the cliff, which is the base. Therefore, the angle at the car will be 47 degrees. We have angle at car equals 47 degrees, and the reason being alternate angle. Alternate angles are equal. Therefore, tagging all the sides of a right angle triangle, we have the side facing our angle to be our opposite. The longest side is our hypotenuse, and the third side is our adjacent. The trig ratio we're going to use will be a 10, such that we have a 10 47 degrees is equal to opposite over our adjacent. 10 47 degrees equals the opposite sides, that's 30, over the adjacent, that is the distance of the car from the base of the cliff, is being given as a d. If we cross multiply, we have d times 10 47 degrees equals 30. Dividing both sides by 10 47 degrees, we have d equals 30 divided by 10 47 degrees. If we punch that in, we have our d, or the distance, equals 27.98 to 2 decimal places meters. Thanks for watching. Bye.